Hi, I'm Nirmal Malapaka. I'm a kernel developer here at Wolfram, and my talk today is core visualization, and it's going to be about core features in visualization functions. In this talk, we'll take a look at some of the core features in visualization functions with a focus on some of the things that we've been working on more recently. So here is the overview of the talk. We're going to take a look at some of the application-specific visualizations we have, and then we're going to take a look at the features that sort of cut across multiple visualizations or multiple categories of visualizations and their design. Then we'll explore a little bit of the core features with some simple examples, and then finally we'll take a look at the new core features and functions that we've recently added and are continuing to work on. So here is a arbitrary categorization of the visualizations that we have. The goal here is to give you an idea of the variety and depth of visualizations that we have. So if we start with function visualizations, here we are leveraging the symbolic aspects of the Wolfram language to plot functions. So we obviously have 2D and 3D plots, but we also have things like slice contour plot or slice plots, which are a kind of combination of 2D and 3D. We can visualize symbolic regions. We can parameterize functions, discretize functions, and visualize them in interesting ways. So as you can see, given any sort of vertical application area, you can have a whole range of visualizations. Same with data visualizations. We have the whole spectrum from the more traditional sort of scientific plotting methods like list plots all the way to custom-built information visualizations like charts. So here's another category of visualizations that target a specific application area, in this case, the statistical applications. So here we use the statistical functions in the Wolfram language to transform the data and then visualize these data in different ways. And finally, we have geographic visualizations where we start off with geographic data and then layer different layers of information on top to create the various geoplots and geocharts. So that gives you some idea of the range of visualizations that we have, but really there are only like a handful of core features in all of these visualizations. So to understand them better, I'm going to break them up into three broad areas: data-based features, layout-based features, and style-based features. So being able to work uniformly with data across multiple functions is important. So there are basically two core features in this area. One is obviously being able to support the various data types that we have in the language. So we'll take a look at how various visualizations deal with things like associations, quantity, weighted data, etc. But then we have the second core feature here, which is to do with data transformations. All visualizations do data transformations, some form of data transformations, and as we come across recurring sort of patterns in these transformations in different visualizations, we sort of make them into a core feature, and scaling functions is exactly one of them. So we'll take a look at that. Then we will move on to layout features. We've had different layouts for charts for a while. So that's one thing we learned from charts, is that it's good to have multiple views of these data in any given plot. And so we've had all these different layouts, and now we're moving towards making layout a core feature and rolling it out to more functions. And we'll focus on the new stacked and percentile layouts that we added to list plot. And finally, for the sake of completeness, I'm going to talk a little bit about the different style features that we have, because these are the most sort of noticeable features that give the unique look to the Wolfram visualizations. But before we do that, I just wanted to mention a few sort of characteristics of these core features. So we want these features to be general sort of solutions that we can apply across multiple functions. But at the same time, we want these functions that use these features to be able to customize the solutions based on the kind of plots that they're coming up with. We also want these features to sort of talk to each other, so interoperability is important, so that they work together, obviously, but also this gives us the opportunity to create some automatic behaviors that are useful to the end user, and we'll see examples of those. And finally, we want these features to be scalable, not just in terms of being able to apply them to as many functions as we can, but also within the functions we want them to be able to scale with data and so on. So the first example that I have of data handling feature is associations. And this is a data type that we have in the language, so we want to be able to do something useful and interesting with it. So here we have list plot, and if you give it an association, a data set as an association, it's going to automatically label the points, it's going to plot the points, and automatically label them with the keys. If you give it an association of data sets, it's going to use those keys to automatically generate legends. So that's kind of a nice automatic behavior to have. You can obviously override that with options and customize the plot, like the third plot over here. And then there are a couple of other things going on here that I want to mention. First, the data handling features is implemented as a core feature, so all of the data functions are able to understand, data visualization functions are able to understand the various data types, and so they can choose to do different things with them. But the second thing is that there are actually two core features that are working here together. One is the data handling feature, and the other one is labeling. So the data handling feature is going to get the information out of the data and pass it on to the labeling feature, and that's going to decide how it wants to label these different points. So you have a decent amount of points in the last plot over here, and then the labeling feature is going to come in and see how to label these points, which ones to label, where to put the label so that it can avoid collisions, and adding automatic tooltips and so on. The second example that I have data handling is quantities. Wolfram language is probably one of the very few languages that natively supports units, so we want to be able to take advantage of that. So here are a couple of a few plots, and we are feeding them data that have units attached to them. And so we have the 2D and 3D versions of smooth histogram, and they're able to detect the units and put them on the axes as labels. We also have deeper integration of units with our plots. So if you look at the last plot, list line plot, it has data which has units attached, and you can also specify target units here, which is in feet, and the visualization functions natively do the transformations on those units and then plot with the transformed units. So you can see feet being displayed on the y-axis for that plot. The last example that I have here is weighted data, and there are two types of plots here. You have a couple of statistical plots up on the top, and then list line plot at the bottom. And we feed in the weighted data to quantile plot, which is plotting quantile against quantile, and it's looking at the data and making the determination that it can use those weights in the internal computations that it's doing, and so it uses that weighted data and then gives you the plot. On the other hand, list line plot is being fed the weighted data as well, but it thinks there's nothing interesting that it can do with those weights, so it's going to ignore those weights and just plot the data. So in this case, doing nothing is also doing something, and we want this kind of automatic behavior to kick in for the user to have a nice experience using different kinds of data types in visualizations. So the second core feature in data is data transformations, specifically scaling functions. And we've had different functions that had specific implementations of scaling. So we've had plots that do log scaling, like the log plot, and we've had bar charts that had specific support for specific scaling functions with the option. And then we went ahead and also added different statistical plots, like the probability scale plot, which does some fancy scaling. Depending on what the second argument to probability scale plot is, it's going to do scaling on the x and y axis. And I think the Weibull distribution thing is getting cut off there, but it's doing log scaling on the x-axis and some fancy log, negative log on the y-axis. So these are specific implementations, and then we made scaling functions a core feature, and in version 10.4 we extended support for scaling functions to list plots, and then now we are extending support for scaling functions to function visualizations, and we'll look at them in the next section. Layout features, again, we've had them in charts for a while. We have a couple of bar charts up top with different layouts, and we have pie charts at the bottom. We've also had specific plots that target specific layouts, like the paired version of bar chart and smooth histogram, where we put the data sets back to back. And so these are kind of specific implementations, and now we are moving towards making layout a core feature, and we've recently extended support for plot layout to the list plots, which we'll also look at in the next section. I also want to quickly go through the style features. Probably the simplest one is annotations. Yet it's quite powerful. Specifically style annotation, you can wrap your data or your functions in the style annotation, and it'll pick up the style and use that in the visualization. You also get quite granular control with for different elements of visualizations with style options, like plot markers, filling, and plot style. These are all quite well known. I'm not going to go into those, but they do serve as building blocks for more sophisticated style features that we'll see in a bit. These days, it's kind of difficult to imagine Wolfram visualizations without legends, but you know, it took a lot of effort for us to make legends a core feature and then implement them and roll them out to virtually all of the visualization functions. And then we have themes, and themes is a core feature that uses all of the building blocks that I just showed you under the style features, and it's a very nice, it's a very powerful feature which kind of ties together a lot of the visualizations under a common aesthetic. It's very easy to specify with just a single option, and it's also a great example of a core feature that is extremely customizable, because each and every plot that uses this feature needs to go in and customize different elements for that plot to get the look that it's going for. And finally, I just want to mention labels. We've had labels for charts for a while, and now it's a core feature which we are adding support for more and more functions. And we're starting to do more and more interesting things with labels. And Min gave a talk this morning detailing how labels work. So if you're interested, I suggest you download his talk or talk with Min. So moving on, the last two sections, I want to focus on the new core features and functions that we've added. So let's start with support for plot layout in list plots. And so here you can see list line plot using a stacked plot layout. And what it essentially does is it accumulates data in the y direction, and so that you get plot with non-crossing curves. And at the bottom, you can sort of clearly see this accumulation happening when we plot it with the stacked bar chart from the previous section. Extending support for layouts to list plots has some issues that need need to be solved. So, for example, irregular data in list plots is an issue when it comes to accumulation. But we are able to solve that using the layout engine which automatically figures out the interpolation of the points between the data points that we have, and then figuring out which of those points it needs to accumulate to the data points. So that's the kind of automatic behavior for irregular data. And we also have automatic handling of missing data, which is considered to be 0 for the purpose of accumulation. Then we have special handling for negatives. And as you can see, we have data that's negative. And so if you look at, say, for example, the third point in the second data set, it dips down to the negative area. So we want to be able to sort of separate those out, but and we don't want any crossings. So here the layout engine is able to figure out a nice way to transition from that point over here in the positive area down into the negative area and give you sort of the visual impression of continuity. This actually works better with the full stack list plot, which I'll show you in a bit, where we have automatic filling. But yeah, this is able to sort of do that at the same time. The second curve is not crossing the first curve. And if you have more negative points, it's going to accumulate in the negative direction this way. And finally, we also have support for percentile layout in the list plots, which accumulates to 100. And because layouts are implemented as a core feature, all of the list plot family of functions can now take advantage of those. And here you can see list log plot using the stacked layout on the right and a more traditional overlaid layout on the left. And again, there are two core features that work here. So the layout feature is coming in and stacking the points, and then the scaling feature is going to scale those stacked points. I'm going to jump ahead a little bit and talk about the new function that we added, because it's really a straight spin-off from the layout feature. So we went ahead and made a separate function for stack list plot. So this gives us some control over some styles, so we can make some unique styles for this. And we're adjusting the plot range a little bit, but we're also automatically filling between the curves to sort of emphasize the stacking metaphor. We also have a stacked version of date list plot, and you can see that it stacks the data, and it also understands the dates in the data. So again, jumping feature that we added, scaling functions. We've had scaling functions in specific implementations before, so you can look at the log plot at the bottom. And to understand how scaling functions work a little bit, here's a sort of simple example. We're trying to simulate the log plot using plot. So the first thing to do is to log scale the function. And then we are, so here I'm looking at the ticks. I'm generating some ticks, and I'm looking at some convenient range for generating those ticks. And the important thing here is to sort of unscale or invert scale the ticks so that we get the values back on the y-axis. And so that's a simple sort of explanation of how scaling functions work. We obviously need to take a little bit more care in choosing the divisions, the intervals here, and how we generate the ticks, and that's exactly what the scaling functions are doing. And also note that we are scaling the plot range here for user convenience. So that's the idea. That's a slight simplification of the implementation for scaling functions. And that's the once we have that idea, we can sort of extend it to multiple dimensions. And so here we have plot which is scaling on the X and Y axis, and then we have the 3D plot, density and contour plot scaling on the X and Z axes. Also note that for contour and density plot, we have legends, which pick up on the scaling functions and automatically scale, so you can actually see that the Z axis is being reversed. And so finally, I want to end with this table that shows the different option values for scaling functions. We have sort of named values for the more popular scaling functions, but you can also specify custom scaling functions by specifying a scaling function and the inverse of it. And this is essentially what I showed you earlier with probability scale plot, which is under the hood using scaling functions. Yeah, so I just want to mention some of the things that we are working on. We have some labeling stuff that you can look forward to in the future. We have some uncertainty visualization. That's a new kind of layout feature that we have, or a new kind of core feature that we have. And then we are also working on more flexible layouts for different plots and charts. Okay, so I think with that, I'll end my talk. And I'll be in the booth downstairs for the next hour if you have any questions. And the whole visualization team worked on all these features that I talked about. So, and some of them are here. So if you have any questions, we can try and answer them now. Thank you.